Hi, Assalamualaikum and a very good morning. So today we're going to do some tutorial discussion for chapter 5, focusing on the subtopic of 5.1 alkanes. So we're going to do tutorial question 2, question 3 and question 5 respectively. Without any further ado, let us start. So for tutorial question 2, we have to draw the structural formula for each of the following compound. So for question 2a, we have to draw 2,2-dimethyl 3-cyclohexyl octane. So in order for us to do that, we need to find the parent chain first. So here the parent chain is going to be an octane which has a 8 carbon straight chain. So the first thing we need to do is we need to draw the parent chain, which is 1, number 1 here, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are all the 8 carbon here. So now there are cyclohexyl attaching at carbon number 3. So what you're going to do is you're going to draw a cyclohexane, but now it becomes a substituent, so it's going to be cyclohexane. Okay, so you draw another line and then draw a cyclohexane. Hexane gonna have 6 carbon. Okay, 1, 2, 3, 4, 5, and 6. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. Alright, and at carbon number 2, they're gonna be dimethyl, means that it has 2 methyl group. So 1 methyl group, CH3, but I didn't draw it out, and then another CH3 here. Okay, so these are the structure for the compound stated here. So if you were to draw it nicely, you will get to be something like this. Okay, so you can label the numbering by your own. And then for number B, we have to draw the structure of 5-sec-butyl 2,4-dimethyl nonane. So we were going to start with the parent name first, which is nonane. Nonane here refers to a straight chain alkane which has 9 carbon. So what we're going to do is we're going to do 9 carbon chain, starting from a zigzag straight line. Here going to be number 1, the starting, and number 2 here. So 3, 4, 5, 6, 7, 8, and 9. Okay, double check. 3, 4, 5, 6, 7, 8, and number 9 here. Okay, now at carbon number 5 here, they're gonna be attaching with a sec-butyl. Sec-butyl here means it is attaching with a secondary butane. Okay, secondary butane. So when it's attaching with secondary butane, means that you can draw a butane first, where butane have 4 carbon, which is 1 here, 2 here, 3, and 4. Okay, so here is a butane, but because it become a substituent, it's gonna be butyl. So number 5 will be attaching at carbon number 2, because it need to be attached with a number 2 of the butyl, secondary butyl here. Okay, and then at carbon number 2 and carbon number 4, they're gonna be attaching with a methyl group. So you can draw another methyl, which is CH3, and number 4 here, which is also a CH3. So you can draw it to be something like this if you were to draw it nicely. Also, you can draw it in, I draw this in terms of the skeleton structure because I find it easy for me. But if you were to draw that in an expanded or condensed structure, it is no problem for you to do that. You are free to choose whichever structure that you wanted. Okay, so that's for question number 2. Now for question number 3, we have to arrange the following alkanes in order of the increasing boiling point, and we have to explain the answer. So we have pentane, 2-methyl-butane, and 2,2-dimethyl-propane. So in order to answer this better, I think you need to draw with the structure first. So for the structure of pentane, you will have 5 carbon chain, which is 1, 2, 3, 4, 5. 2-methyl-butane, you have 4 carbon chain, and then methyl group at carbon number 2. Okay, so 1, 2, 3, 4, and then the methyl group going to be at carbon number 2. Now for 2,2-dimethyl propane, it's going to be 3 carbon. Okay, 1, 2, 1, 2, 3, and then 2 methyl group going to be attaching at carbon number 2 here. Okay, so it's going to be 2,2-dimethyl propane. So what you can see here is that pentane has no branch. Tiada rangkaian, tiada substituent. But for 2-methyl butane, there will be one substituent or one branch, and then number 2,2-dimethyl propane will have two branches, which is one branch here and another branch here. Okay. Okay. Now you know that even though they have the same molecular formula, which is C5H12. Okay, so you know that the same structure will have the same molecular formula, but their structure are different. So they are the effect of branching. So in order for you to explain this, you can say that pentane is a straight chain alkane, straight chain molecule or alkane with no branches, and the two methyl butane has one branch. Okay, 2-methyl butane tadi hanya ada satu rangkaian saja. Meanwhile, the 2,2-dimethyl propane is the most branch molecule which has two branches here, and it is the most compact molecule compared to the others. Okay, so basically bila dia ada banyak rangkaian dia akan menjadi lebih compact berbanding dengan yang pentane tadi. Okay, kalau pentane dia adalah straight chain alkane and they are more long and linear, so they can have more surface area. Tapi bila dia compact, they will have a lesser surface area. So for molecule with the same molecular weight, which is C5H12, the branching will reduce the surface area. So the lower surface area means that it can form lesser van der Waal interaction with another molecule, and hence will have a weaker van der Waal forces overall. So we can say that the boiling point will be decreasing from the 2,2-dimethyl propane, lesser than the 2-methyl butane, and the highest boiling point going to be pentane. Okay, so pentane will have the highest boiling point. All right. Now we go for the tutorial question 5. So for question 5, a mixture of propane and bromine is exposed to sunlight. So propane is an alkane, and the equation is given as here. So alkane reacting with bromine in the presence of UV, and they will give two possible product here. Okay, so we have to state the type of the reaction. So from here, you know that when a bromine gas is included with the presence of UV, it is a free radical substitution where one of the hydrogen can be substituted with the bromine. Satu hydrogen tadi akan digantikan dengan bromine atom. So it's going to be a free radical substitution, and UV helps them to initiate the chemical reaction. So the next question is, what is the function of sunlight interaction? So the function of UV, which comes from the sunlight, will be able or helps the reaction to provide enough energy to perform homolytic cleavage. Okay, so they're going to provide energy for the homolytic cleavage. And now for C, we have to draw the structure for the mono substituted product A and B, identify the major product. Okay, so the meaning of mono means that one hydrogen going to be substituted with bromine at one time. Okay, so apakah possible product yang akan muncul? So if in this case we have CH3, CH2, and then CH start with 3, right? Now we're going to change it into 2, and one of the H going to be changed into Br. Okay, so one of the H will be changed with a Br atom. So this is one possible product. Another possible product is that CH3, so this is not affected, and maybe one of the hydrogen here can be changed with Br. So you can say that CH and then attach with the Br here. Okay, so if you want to put as a condensed structure, you can also put it as CHBr, CH3 here. Okay, so you know that the hydrogen can be substitute, the bromine can substitute the hydrogen here, or you can substitute the hydrogen in the middle. Okay, so bromo maksudnya satu, so hanya satu hydrogen yang akan digantikan. Alright, so in this case, one of them is the major product and one of them is the minor product. So basically here gonna be the major product, because in the substitution reaction, this gonna form a secondary free radical. Meanwhile for here, they only produce primary free radical. Okay, and Br here is situated at carbon number 2. Okay, so you can say that CH3 CHBr CH3 is the major product, and then the other one, which is CH3 CH2 CH2b, are going to be the minor product. Now we have to write the mechanism for the formation of the major product. Okay, so for this case, we're going to do that in the next slide because it is kind of long and couldn't fit in this page. Okay, and for question number E here, we have to give the observation for the reaction. Okay, so starting up, we started with a bromine gas and bromine molecule here. So you can see that the color of the bromine gas is basically reddish brown, right? But then the bromine molecule gonna break apart due to the homolytic cleavage. So what really happened is, so when the bromine molecule is broken down, you know that the color gonna get decolorized. Okay, pasal mula-mula bromine gas tu adalah reddish brown, but now because at the end of the reaction, the bromine gonna be substituted here. So you can see that the reddish brown color gonna be decolorized. Okay, so it's gonna change color from reddish brown to colorless. So now for part F, what will happen if the mixture is kept in the dark at the room temperature? So So now on part F, what will happen if the mixture is kept in the dark at the room temperature? So when the substance is kept in the dark, there will be no UV. So when there is no UV, tiada UV or no light, the chemical reaction will not take place because it unable to provide energy for the homolytic cleavage to occur. So basically the bromine gas, which is reddish brown in color, will still be maintained. So the reddish brown color of bromine remains unchanged. Okay, so now we're gonna come back to question D and do the formation for the major product, which is the CH3 CHBr CH3. Okay, so now in order to write the mechanism for the formation of the major product, you need to remember that we have three important steps, where in step 1 we have initiation, for step number 2 we have propagation, and for step number 3 we have termination. Okay, So for step number 1, initiation, so we will have the bromine molecule, and the bromine molecule will be broken down with the help of the UV. So the UV here is compulsory. So the UV will provide energy to the bromine molecule, and then they will be dissociated by the homolytic cleavage. So the bond here gonna be broken down, and one of the bromine atom will receive one electron. So the transfer of one electron is represented by a half-headed arrow. Okay, so half-headed arrow refer kepada satu electron. So what gonna get in part 1, which is the step 1 here, we will get 2 bromine free radical. Okay, so the initiation means that it is the production of the free radical of bromine. So now in step 2, we will generate another free radical. So the alkane that we have in the earliest slide is we have CH3, CH, CH, CH3. And then I draw it this way because you know that we're going to substitute the carbon number 2. The carbon number 1, carbon number 2, and this one is carbon number 3. So the bromine free radical that we have produced in part 1 going to be carried forward in step number 2. So what will really happen here is that the bromine free radical will combine with the bonding due to the breaking of bond, and then this is going to be combining with the Br free radical, and one of the electron going to be transferred into the carbon, because you know that one single bond here refers to 2 electrons. So one electron is transferred into carbon, another electron is transferred in order to form bonding with Br. So at the end of this reaction, you will get the carbon free radical, which is like this, which is CCH3, CH3H, and then one electron here, and then you will produce HBr. Okay, so HBr is our byproduct. Now, this molecule here can now become the free radical. So this free radical can react with the bromine that is a lot in the reaction. Okay, so the free radical of carbon can react with another neutral molecule of the bromine. So this gonna initiate another formation of bromine free radical. So this bond will break apart, and then this will form a bonding with the carbon free radical here, and this is going to produce CH3Br, H and CH3, and then these are referring to our major product that we talked just now. Okay, and at the same time, the bromine radical will be produced once again. Okay, now we're going to do into the termination step. So termination means we have to stop the reaction. We have to stop the production of the free radical, because or else the free radical will keep on producing and producing and producing. So at one point, the radical need to be combined together in order to stop the generation. So what we're going to do is that the bromine free radical will reacting with another bromine free radical. So they will combine together in order to form bromine molecule again. At the same time, the free radical of the carbon, which is we have a lot of free radical actually that are surrounding the molecule, that surrounding the reaction in the reaction mixture, and then this will basically collide with another bromine free radical. So they can also combine together in order to form a single bond, and this gonna give our major product, which is CH3, CBr, and CH3 here. So this again will give us our major product. Okay, and at the same time, there might be a tendency of the free radical to meet with each other. Okay, ada kebarangkalian untuk free radical yang carbon tadi akan bertemu dengan free radical yang berada di sekeliling dia juga. So basically they can combine with each other in order to form alkane. Okay, so this is going to be the type of alkane that going to be produced here, which is also our byproduct. Okay, so I think that's all for tutorial discussion chapter 5.1. See you again some other time. Bye.